Till now we have completed a lot of topics, and if I talk about what are the topics left till now, we have completed conditional part. Loop is left now, loop, and in the especially CMI you'll see that lot of questions are from the loop. That's why this loop is important. And after that we have a function. So function questions are also there. So these are the topics, for which questions are there. And that's why we were building a lot of base for ourselves for these topics. And apart from that, there are topics like array. So array, it's a collection of element. There are a lot of questions can be framed based on these element. Like let's say some array is defined, and you are storing some element, and then it can be asked, like maybe you are trying to access this array, trying to sort this array, trying to sort some element in this array. So we'll see like how to, like how what kind of operations can be defined in this type of array. And so these main topic are loop, function, array, and some topic of data structure. So mainly I saw that ki binary tree and binary search tree. So these basic concept we will touch at least, so that we will be able to do at least all the questions that have been asked. And the pattern follows from the same thing. Questions from the loop functions are going to be there. Array. So these things are the topics that we will be entering now. So we will today start with the loop in C programming, and we will also see a lot of different questions. So I think means of seven lecture will be enough from today. 7 lecture will be enough to complete the programming part. So mostly one lecture will be gone function, uh, maybe one will go on array, and for loop I think there will be two lectures, so 2 to 4. And for this array, binary and binary search tree, let's keep it two, because there are other additional topic that you want to touch. Six lecture are there, and one lecture we will just see what the other topics are left. So 7 lecture will be enough. And meanwhile we'll also do some questions that has been asked in the CMI, and we'll also keep other means, once programming part is finished, we'll also keep some problem solving session once a week. And then we will now start focusing on some other part like probability and maybe discrete math or some mathematical portion. So we are actually, I think in 7 lectures we'll be able to at least complete all those topics with good understanding of how to solve the questions. So means from now you have to actually be focused and actually try to put more effort on learning these things, because these things are the main thing that is actually asked in the paper. That's why these things are important. Okay, so from now I will expect you will just put a lot of focus. And especially a loop is something that if you understand clearly, you'll be able to do a lot of programming questions, especially if you are trying to write some program, or if you're trying to write the output of a program. So both where loop is something that is somewhat difficult, because a simple loop, understanding simple loop is easy, but when a nested loops comes, or some variation of loop is given that you can't understand, so that's where it's become actually difficult to do the looping. But yes, there are a lot of programs that can be based on loops. So like there is a popular program. So let's say for programming like this. So in first line there is 1 star, second line there is 2 star, third line there is a 3 star, fourth line there is a 4 star. So user will give out input of n, and based on that you have to print, this way. First line may 1 star, 2 star, 3 star, 4 star. This way you have to print. Other variations can be, like a print inverted triangle. So let's say n is equal to 4, then here 4 star is there, then 3 star, then 2 star, then 1 star. So in this way, so there are a lot of variation of these type of things are there. And but yes, the time does not allow you to actually do a lot of programming questions. But yes, at least you will see the basics and actually how to solve any output type of questions. Okay, so this thing is there. And it was really important. I think I should told you, because from now you will be entering into the advanced topics. Okay, then just let's start with the today's class. Okay, so actually we saw that ki conditional, in the conditional part we saw that ki if you want to run, means if you are running some particular line of code, and let's say you want to skip this particular line of code, or you want to run this code because some conditions are satisfied, then we go for the conditional statement, if else. And we also saw a lot of like how to make conditions, how to join condition by and, or maybe sometimes not operator, how to write nested if else statement. So these type of things are there, and you have to keep those things in mind. But in for now, let's say you have some portion of code, let's say you have a lot of codes, and you want some particular line of code to run two times or three times. Okay, so it may happen that you are trying to write a program to find simple interest. Okay, so someone says that okay, you just make a program to write simple interest, but you have to write this program to run 10 times. So first time the user will input p, then n, then r, then you have to calculate the simple interest, then again you have to do this, again you have to ask users for p, n and r, then again you have to do this, and you have to do this 10 times. Okay, so these things are there, and in the real world loop is something like more important, and you can say that a crucial part of the program, because a lot of times it will happen that you have a array of elements. Okay, so let's say you have 10 elements in an array. Okay, so it may happen that you have need to access each element one by one, and then you need to do something on this element. Or it may happen that you have to just access the odd element, and you have to do something on this element. So these type of things are actually comes under the application of loop. It is not, let's say you have stored some data in a database. Okay, and you have to access database each by one, and then you have to do some operation on those database. Maybe you want to delete something, or we want to add something. A lot of different applications are there for the for loop. That's why it's something uh, very much useful in the real world, and a lot of problems can be framed based on that. So and specifically, these things are there to run a part of program a specified number of times. Let's say you want to run program four times or five times. So these things are there. So we'll see how we can do that. Okay. So there are three ways we can do that. There is a for loop, there is a while loop, and there is a do while loop. The three types of loops are there in the uh, C programming. So like basically you understand a loop, how a loop works. You will actually is working with both the things, or maybe sometime the while loop is do while loop is also there. So for loop and while loop is the most important, and if you understand the working of the for loop and while loop, you'll actually able to do other types of loop also. So those are just what you can say extension of these two things. So let's see start with actually how the loop works. Okay, so there are actually three ways we can do the looping part. And loop actually simple means that you want to repeat some part of program a specified number of times. Okay, so that's what the introduction of loop is. Okay, so like if you talk about the while loop. So okay, let me. Okay, so initially, what happens that actually I've been introducing a lot of flowcharts. So before seeing looking at the syntax of while loop, let's look at how a loop actually in general works. Okay, it's a simple thing. Okay, just when you initialize a program, okay, you test some condition. You test some condition. Okay, let's say you want to run something 10 times. Okay, so with you may start I is equal to 0, and you will compare if I less than 10. Means you want to compare run this thing, uh, sorry, I is equal to I plus 1. So let's say you want to run this particular program 10 times. So you will start with I is equal to 0, and we'll check whether I less than 10 or not, because it want to run it 10 times. Okay, if it's true, then you run the what has been the code in the loop. Okay, so let's say if the loop has some particular line of code, you run that code. Okay, and then you do some increment, because you want to run this 10 times. So each time you compare something and you increase the value by 1, then you again do the same thing. You again come back and then make the comparison, and if it's true, you again repeat the same thing. I mean, if it's false, then you stop the program. Okay, but like this thing is a bit difficult to understand. So let's say, understand what is the syntax of initializing a loop in the while loop. Okay, so while loop actually works this way. Okay, so let's understand this syntax each line by line. Okay, so first what you need to do, you need to initialize a loop counter. Okay, so what do you mean by loop counter? Loop counter is a variable, so it may be integer, it may be float. So it is a variable which is actually initialized to count the number of loops. Okay, so it's something that controls the loop. So let's say ki, I told you na, ki I is equal to 0 and I want to run this particular code 10 times. So when you define I is equal to 0, when you are incrementing I plus 1, so these things are there, and this I is called loop counter. Okay, so loop counter is something, some variable, and it actually control the loop. Control the loop means it will just check whether the a particular thing is greater than some number or not, and that's how a loop counter works. Okay, how to define the while loop? Just write the keyword while, then inside the parentheses, so these parentheses are important, you write some condition. Okay, because why this condition is important? Because obviously I told you na, कि you want to run a particular item code 10 times, so you'll be checking that particular thing 10 times. Okay, you initialize something, you compare it with something, and then you increment that particular thing, and so we do this by some condition. Okay, and if the condition is specified, then this particular line of code will run, which is in the curly braces. Okay, so you run this particular line of code, some do something, then again do something, and then you can write multiple line of code there, and then at the end you need to do this thing, increment loop counter. Okay, so let's say you have initialized I is equal to 0, so you need to increase I by some number. Okay, that's important thing. Incrementing is the important thing, and it actually considered most important thing. So like let's just take this thing into action and just understand this thing with the example. Okay, so thing is that you just focus on this particular line of code, just this particular line of code. We know that this particular line of code is actually used for finding the simple interest. So what it will do, it will take, just focus on this shaded area. Okay, it will take value of p, n, and r from the users. Okay, user will input p, n, and r. Okay, then what it will do, it will calculate the simple interest. And how it will calculate it? Using the formula p into n into r divided by 100. So it will calculate this particular thing. Okay, and then what it will do, it will just output the whatever the simple interest is calculated. Okay, just focus on this part. So let's say we want to run this program 3 times. Okay, so we need to use while loop. I told you, for doing this thing, either you go for with the while loop or either you go with the for loop. So we will see those things. Okay, so what you need to do, first you need to initialize a loop counter. So count is equal to 1, here is a loop counter. Okay, so it's a loop counter. Why it's a loop counter? You can see that same thing is being compared here. Count less than equal to 3. So what happens? Just let's now focus on it. So count has been initialized with 1. Count less than 3. So if it's 1, initially it is less than 3. Okay, so this condition is true. If it's true, what will happen? It will go inside the body of the loop. This is called body of loop. Okay, body of loop means whatever is inside this curly braces, because whenever this condition of this loop is true, this body of loop will be running each code line by line. Okay, so this is called the body of loop. Okay, so let's say this condition, particular condition is true, then what happens? Then it will run the every code line by line. So it will run this code, then this code. So you can say that it will ask for the inter values of p and r. If you enter the values, it will give you a simple interest. Okay, okay, so when this particular line of code is executed, then it comes to the count part, and it's where the incrementation is done. Okay, so increment, I told you increment is important. I told you this increment loop count is important. So count is increased by 1. Okay, so now the count value of the count is equal to 2. The value of count is equal to 2. Then again it will compare count 2 less than equal to 3. Yeah, it's true. If it's true now, so what it will do, it again to repeat the same procedure. You can see that same line of code has been repeated again, and we have entered some other value of p, n, and r. Then again count value will be increased from 2, it will goes to 3. Okay, again it will be compared, again everything will be done. Again you will see that a different line of output will be there, and then you entered some p, n, and r, and then you can get an output. And now the value of change from 3 to 4, again it will be compared, but it will now found that 4 less than 3 is equal to false. It's a false statement. That's why this particular line of code will not run now, and the control now comes out of the loop. So whatever the next line of code is there out of the loop, outside the loop, it will be running now. So the program comes to an end. Okay, so this is how actually a loop works. Okay, so first thing is that you need to initialize a loop counter in the while loop. Second thing is that when this particular condition is true, you need to run the code what we inside the loop. Third thing is that you need to increment a particular thing, and as means till the time when the this particular thing is true, it will be keep running the same code, and when it will be false, it will come out of the loop. Okay, so this is how actually a while loop works. Okay, any questions, guys? If you are studying it first time, or maybe know, if any questions you have, just let me know. Anyone, any questions? Please let me know. And if it's okay, then I will move ahead. Guys, is it okay? Okay, so this thing actually come into, if you just understanding it first time, you need to spend some time, and if you're just aware about something, just need to put a step by step focus on how actually the things run line by line. Okay, so just we will be looking at some heavy examples as we proceed. So the condition that I told you, in while loop, you actually have some condition. Okay, some condition you write there. Okay, and then you have this particular line of code. Okay, so this condition can be can be what you can say. Condition may be tested using relational logical operator. So it may happen that you write a single line of single condition. Maybe write two condition that is joined by an AND operator. Maybe you write multiple conditions. So see these multiple conditions, and you are actually joining this by and operator and or operator. So you can write multiple types of condition based on whatever is your requirement. Okay, so this thing is important because sometimes when you actually run a lot of programs, you will see that key in while loop you may need to test two conditions simultaneously. Okay, two conditions is there simultaneously. Okay, so let's say कि you are asked to print all the odd numbers between 1 to 100. Okay, all the odd numbers you need to print between 1 to 100. So let's say how you can proceed it using loop. Okay, so can anyone just tell me the overall idea if you want to print odd numbers between 1 to 100, how you should proceed? Anyone? Yeah, yeah, so means how we will proceed. Yeah, so loop we need to use, right? Hello. Okay. So what will be the what will be this loop counter? So when what will be the loop counter? From where it will start? Yeah, it will start from one. Yeah, count is equal to one. Then we'll use an while loop. Okay. Yeah, and count less than equal to 100. Okay. And inside the loop, what it will do, we will just need to compare whether it's a odd number or not. Okay. And for that, we put an if condition, and if count modulo, okay, 2 double equal to, okay, okay, if it's there, then what you need to do, you need to, yeah, I put a equal equal, right? uh, Printf, and then print that number percent d, whatever that number count is. Okay, and then again increase the count by 1. Okay, increase the count by, yeah, same thing means no, that's the correct program, but same thing can be, if you want, you can do this thing somewhat differently also. So let's say just you started count by 1, and you print the count. Okay, you just don't put this if here, just to print the count, and you increase count by 2. Okay, what you are doing, you are increasing count by 2. So from 1 it will go to 3, right? From 3 it will go to 5. So it's not like you can always increase count by 1, you can also increase count by 2 also. Okay, so you can write count is equal to count plus 2, and you don't need to put any if condition here. So in that case it will also print the odd number, right? Okay. So yeah, so this is there. It's not like any hard and fast rule. You just need to increase something by 2, or just need to increase something by 1. You can do increase it by anyway, as soon as this condition will keep satisfying. The overall whole the numbers will be keep printing. One more thing. Okay, so it's not like now you just need to increment something. You can decrement also. So let's say you started count by 100. So let's say you started count by 100, and you want to print the same thing but in the reverse order. Sorry, 100 is there and you want to print the same thing but in the reverse order. Okay, so how you can do that? So the same thing is that he just initialize a while loop and count. Now just put count greater than equal to 0. Okay, and print count, print whatever this particular thing is, print that, and increase that particular count. Uh, yeah so like count is equal to count to minus 2, so it will essentially start printing the even number. So if you start with the 99 or 101, so then will start printing the odd number, right? Yeah, means since we are starting with like 100, so first it will print 100, right? So that's why if you want to print the odd numbers, you may start with 101 or may start with 99, right? Yeah. As additionally, there are a lot of things you can do. If you starting with 100, also just then start printing count minus one. Okay, so it will also be helpful. So whatever the thing is that I just want to tell it, you can not only increase, you can also decrement something if you want. But three thing is important. Just whatever your counter variable is, whatever condition you are defining, that should be important, because like this should be satisfied. Then only when this thing will run, and this increment or decrement thing is important. And like whenever you miss something in between these things, you will actually be getting into infinite loop. Okay, so we'll see some example of infinite loop and how this infinite loop actually occurs. Okay, so till then it's good you are understanding the things and you can write some program. So things that single line of statement can also be written without parentheses. Okay, so like in if statement, I told that if writing some if statement, and if it's a single line of instruction, you can just skip the curly braces. You can just skip this curly braces. So the same thing is with a while loop. So just say you want to print a single line of, you want to do something with a single line of instruction. So you can just write while whatever the thing is, and then you can write the single line of instruction. Okay, so you can just skip this curly braces. Second thing is that decrement part I already told, and third thing is that you can also use float variable. It's not like we are always using int. So it's not necessary. You can also use float variable as a loop counter. So let's see some example of that particular thing also. Okay, so let's see some other examples of while loop. Like this program is actually everyone do while they learn the programming. So it's like a calculating the factorial of a number. So like if n is a number, so n factorial actually defines as n minus one, then n minus two, and this way up to uh, 3 into 2 into 1. Okay, so let's see how we can calculate the factorial of a number using while loop. So can anyone just without looking at the program tell me what should be our high level idea towards approaching this code? Just for now, just don't look at this code. Okay. So anyone just tell me what should be our main aim towards solving this factorial of a number problem. So they essentially the thing is, yeah. So hmm, hmm, hmm. Yeah, yeah, and we can store these things, and at the end we will have this factorial. Okay, so essentially same thing has been done. So we have initiated two variables n and fact. So in fact we, yeah. So in fact, we will keep storing the number. Okay. So as soon as you multiply the numbers, we need to store it somewhere. So like for now, just for the sake of just now, just see that this variable is something that we have not initialized with one. We'll see why this particular thing is important, why it should be initialized with one. So what we will do, we will enter a number. So let's say user enter five. Okay, five is entered. So we have entered, taken the five, and what we need to do, we just need to compare the condition if n is greater than 0. So let's just see step by step what's happening. So it's essentially 5 is greater than 0, then our particular thing is calculated. Fact is equal to fact into n. Okay, so fact means, let's say if n is equal to 5, then this thing will be fact into 5. Okay, so if you are not initializing this factorial with any number, it will be taken a garbage value in the beginning. So I told you somewhere कि if you don't initialize any variable and if you are trying to use it in the program, it will take some garbage value. Okay, so what should be the ideal number with which fact should be initialized? If you initialize with a zero, like mostly we do with integer, it will, if you multiply with something, it will make it zero, so that's not important. So that's why we initialize it with 1. So initially what will happen, fact is will be calculated, fact in is equal to fact into 5, which is 1 into 5, which is 5. So now at this point of time we have 5 stored in the fact. So fact now is 5. Okay, what it will do then, it will decrease the value of n by n minus 1. So now n was 5 years, n will become 4. Okay, next thing, again the condition will be checked, if 4 is greater than 0 or not. Yes, it's still greater than 0. Then same thing will be calculated, and fact is equal to fact into n. So instead fact is equal to 5 now, and n is equal to, okay, what n is equal to, n is equal to 4. Okay, so it will be calculated 5 into 4, and it will be equal to 20. So fact is will equal to, in the next step, fact will be equal to 20. Okay, and n is equal to 3, because at the point of this point of time this particular thing will be done. And same thing will be repeated until n is equal to 1, and this will be calculated as 5 into 4 into 3 into 2 into 1. Okay, so this thing will be calculated. When 1 will approach, it will again make it 0, and it will compare if 0 is greater than 0, which is false statement, and then it will come out of the loop, and thus our factorial number will be there in the stored in the fact variable. Okay, so means, do you have any problem understanding this program? So like if some particular code is there, like this is the way actually you, what you can see, you do the dry run. Dry run is something that I talked earlier, and dry run means, you are just trying to understand the program on the paper, and you are trying to run everything on the paper. So if you are given some problem in the any exam, you just need to especially when you are dealing with the loops, you need to write everything step by step, and when like you do three four step, you will actually have idea of what this particular line of code is doing. Okay, and based on that you can simulate the output. Okay, that's why to do the dry run, the most important thing is you need to do this particular kind of calculation step by step. So anyone have any questions or any suggestions? Okay. Okay, so fact, let's say we don't initialize fact with any variable. Okay, let's say we don't have this particular thing. So if n is greater than equal to 0, okay, so we are trying to store this particular factorial number in some variable. Okay, so fact is equal to fact into n. So when n is equal to 5, initially n is equal to 5, what it will do, it will check this condition, and it will run come inside this loop. So fact is equal to fact into n, it means fact is equal to fact into 5, because n is equal to 5. But we are trying to store this particular value, particular factorial thing in some program. Okay, so let's say we just we don't initialize fact with any variable, because initially, what we want to do, we just want to keep multiplying the number and keep decreasing by 1. So just take the n, keep multiplying by itself, and just keep decreasing by 1. So essentially we will get this particular thing. So let's say we don't initialize fact with anything. So what it will do, it will do fact is equal to fact into 5. And if you don't initialize fact with any variable, it will take a garbage value. Okay, and whatever you are storing in the fact, it will become either very large number or very small number that will don't make sense to you, because some garbage value has been taken. So to avoid those particular things, we take fact is equal to 1. So what it will do in the first step, fact is equal to 1 into 5. Okay, so now the fact will be means, in fact, we can, the value of 5 will be stored inside the fact. Okay, additionally you can do some other thing also. Okay, what the particular thing is that, you may, so that particular thing is different, but this way you can proceed. Or may, you take the value of n, and we store that particular value of n in the fact itself. Okay, and you repeat the same thing, but you repeat the same thing with the n minus 1. But that's the complicated program, that don't need to pay too attention. Simple thing is that you just keep multiplying same numbers with the fact, and initialized fact with 1. So did you understand, like, why did we do that? Or tell me what you understood. Okay, so what did you understood means? Yeah. In the while loop. Yeah, definitely. Anyone, any problem, any questions? Okay, so like I told, ki, you don't need to deal only with the integer variables. You can also deal with the float variables. So similarly, you can define the float number. Okay, and you can just, yeah. Yeah, I told ki means, like after lecture I told ki just I'll provide the slide and just need to write the program and run. So I'm telling this thing from the beginning. So actually I can do that, but like running the each program, writing this program line by line and on the screen, so it will take a lot of time for me also. So that's why. Yeah, definitely. Yeah, definitely. Like earlier explained ki how this particular things go. Yeah, that's why I yesterday told ki just write this code and like try to modify something on your own. Like whether you had been thinking ki what would have been happen if fact not equal to one, and try to see what is happening. So you may see some kind of error or some other type of things, and that is actually important. Like it may happen that in the output of the questions in the exam, it may happen that some everything is given, but fact is not in slide with one, and it actually wants to check you if you know or not you what will happen if fact is not in slide with one, whether it will be a garbage value, whether it will be given error or something else. So that's why I told an important thing. Yes, my part is I can just make you understand a dry run, but I cannot means it's a limitation that I cannot show you because you have a limited amount of time to complete. So that's good thing. You should you means always try to take the slides from me and try to run the code and do some modifications from your side. So that is important. Okay. Okay, fine. Thank you. So, like loop counter, I told you just you can use this thing as a float also. So, the same thing is that is initialize any loop counter. Okay, so this is the loop counter. And what you need to do, you need to write some condition based on that. So maybe less than or greater than. And, like try to print this thing and try to increase it by some small number, maybe 0.1, 0.2. So you can see that it will just print 10 in the beginning. Then 10 will be updated to 10 plus 0.1, this 0.1, which will become 10.10, then it will become 10 point, sorry, 10.1 plus 0.1, which will become 10.0, 10.2, and similarly it will keep printing all the variables until it goes toward 10.5. So like when 11.5 will 11.4 will come, it will add 0.1 there, it will become 11.5. So like comparing this thing with this particular thing will give you result of false, and if it had been equal to here, it would have been given result of true. Okay, that's why this particular thing is important. And like we can do the same thing with the integer, we can do the same thing with the float. Okay, so this is fairly simple. It's not like if we only use the integer or something else for the loop counter. You can also use float variable, and you can do the simulate this particular thing by this way. Okay, so one more thing I wanted to tell you, like in CMI paper, there are a lot of sections, like mathematics is there, probability is there, discrete maths is there, programming is there. So, like sometimes students think that we will do this particular three portion and we'll skip the fourth part. Okay. So, like what I would have been looking at the CMI is that you actually needs to attempt questions from all the four sides. So it's not written anywhere, but there was one of my friend who actually attended three section and did almost everything correct. In fact, he was getting more marks than some of the students who actually had done all the four section. But he was not selected, and those students were selected. That's why like it's don't think that he will just skip the probability part, or will just skip the what I can say maths part, or will just skip the programming part. So this thing is not going to happen. You have to attempt the questions, you have to do some certain questions correct in each category. Means this is the thing that I have found from my own understanding when I was taking the exam. Okay, so this is why like it's important you understand each and every syllabus correctly, and you do questions from each part. Uh, is it clear now? Okay, so the most some simple thing is there. Like this thing actually there that need to be focused on. Let's say this particular program has just some mistake. Actually, not some mistake. You can say that some thing has been put and some attention has not been paid. So you can see that after the while loop there is semicolon. So like any program that we have seen till now, any while loop after any while loop, we don't pay any semicolon. Don't put any semicolon, but after while loop, if you put any semicolon, you know what it will understand. It will understand that this particular line of code has means like this particular line of code will understand this is a single instruction. This is a single instruction. This particular line of codes are the different part. Then it's not a part of while loop. Okay, because I told you in the semicolon, it means that it's the end of the what you can say. It's the end of the single line statement. And while loop specifically, we write some condition, and this body of while loop is defined by curly braces. But if we put semicolon here, it will just think that this is the end of while loop, this particular thing, and everything that is written here, it will be ignored as the part of while loop. It will not be counted as part of while loop. Okay, so in this condition, you know what's happening? We are initializing I with 1. We are comparing if I is less than equal to 10 or not, but we are not able to increase the I. Why? Obviously because we have we have by mistake put here the semicolon, and it's understanding this single line of code is different. Like it's a different, it's completely different, and it's this these below things are not a part of this long things line of code. So what do you guess? What will be the output here? Yeah. So, it is because I is equal to 1 and I less than 10. And this condition is not, means the execution has gone into the loop, but it's not coming out of the loop, because I is equal to 1 is always going to be less than 10 if you don't increase I by 1, or if you don't decrease. Okay. So, I less than 10 is always there. And if you don't increase by any number, I is by any number, it will always going to be less than 10. So, a blank screen will appear, and nothing will be happening. But program is running and it's in the infinite loop, and this thing is not coming out of this while loop. Okay, so this is also an example of infinite loop, and infinite loop occurs only when condition is true forever. So whatever condition you are putting, it's true forever. That's why I told you this incrementation part is necessary, because if you not put the incrementation part, you will not get this condition false anytime. And if you not get false anytime, it will just keep running the same line of code, and some random output will keep appearing on the screen. Okay, so like when we used to run the code, so there was a software called code blocks. So we did not use online compiler, we used to use code blocks. Okay, so yeah. Yeah, yeah, means this particular line of code is it's a complete line of code, right? Yeah, definitely. So I was telling you, like this thing is there. So some compiler throw an error, and some compiler actually I told you C has been there for like past, you can say, many years. So some compiler actually throw error, some compiler will show the blank screen. So definitely like this particular thing. Sometimes these particular things depend on some compiler, and whether you are running online or whether you're running the code blocks. So that's why I was giving the example of code blocks. In code blocks, when we used to run the infinite loop, so the computer a screen will appear, and a random output will keep appearing, and this thing go forward until you cross this particular thing. But on online mode, when I run the program, I just found that it will just run a few number of times, and then the program will stuck. Okay, so it depends on compiler by compiler ki what should be the output. But thing is that you should not make this mistake by understanding that this semicolon and this still is the part of the program. So this thing should not happen, right? Guys, any questions? Is this thing clear now? So I just want to tell you, just don't try to put like a semicolon after the while loop. So this thing don't make this curly braces and whatever the statement written inside is the part of while loop. This thing does not make that particular thing. This thing has different meaning, completely different thing. Yeah, definitely. So like whenever you want to make this body of loop useful, just like just simple syntax is while and some condition, and then just inside the curly braces write whatever the program you want to run. And this condition should be like based on this counter variable, and the counter variable counter loop, whatever the thing is, you just need to increment or decrement it certain number of times. And it may happen that like there is another way you can just enter into the infinite loop. So we'll just discuss the thing, but the main thing is there. You just need to put some condition, and this condition should be incremented or decremented some number of times. Okay, so infinite loop I was talking to. So let's see this program. Okay, so so number is means this is a float which is initialized with 10, and we're comparing if num is greater than equal to 10 or not. So instantly, if 10 is num is equal to 10, num greater than equal to 10 is satisfied. Okay, and sorry, num is satisfied, and this print statement with 10 will be printed on the screen. Then it will increase num by 0.1. Okay, so 10.1 it will be. Okay, then again it will make some comparison, and it will again means it's instantly this is also greater than 10, and it will keep printing this term. So this is instantly means this is actually a example of like infinite loop, because we are not able to get out of the loop anytime. So so means, do you see why this thing is coming as infinite loop? Means what are the mistake that we are making, or what should we do to avoid that? Okay, yeah. Yeah, means we are, so what we should, yeah, so what should we do to make this thing like end sometimes? Means what means where we can pay the attention, like there are three things. This, okay, so if you run less than equal to 15, yeah, yeah, we can also do that, and we can also know less than equal to 15. So till the point 15 is reached, we can do that. So like there are multiple ways you can just avoid the infinite loop. So the first thing is that anyone told you just optimize this condition. Someone told you that you can make this thing actually go in some other way. So these things there, like whenever some infinite loop problem is there, just how to optimize it actually comes in these two places. Mainly these two places will be there. How you are writing the condition and how you are incrementing the variable, and modifying these two things, maybe sometimes simultaneously, maybe sometimes individually, actually make you come out of the loop. So instantly when you are running the program, and if its output is coming 100 number of times, it's keep repeating, then you are in a infinite loop problem. And then if you want to what you can say, if you want to improve that program, you want to bug that program, the simple thing is that just need to focus on the condition or some incrementation what's happening there. So it may happen that this particular while loop has like 1,000 line of code, but most the thing is that mostly the problem is either there or there. Okay, so these two thing will be there when you want to compare or just get out of the infinite loop. Okay, so like we have been doing a lot of I is equal to I plus one. So like this particular thing has a modification. Okay, so let's say we want to print an integer from 1 to 10. Okay, so 0 to 10 we want to print. So if this program is there, so what it will do? It will just start with the zero, and it will keep the number, keep printing the number till 10. So zero, one, dot dot dot. This way it will keep printing numbers till the 10. And each time we can see that we are increasing the number by one. But same instruction can be constructed in this way. Okay, so this whole program is same, but thing is that num is equal to num plus 1. It can actually be modified as num plus plus. Okay, so this increment operator plus plus increment the value of I by 1. So every time whatever the when this particular line of code is run, it increases the value of num by 1. and every time the statement this particular I plus plus get executed. Similarly, to reduce the value of variable by one, we can use the decrement operator. So I plus plus or num plus plus, these things, this particular operator is called increment operator. Okay, and similarly I minus minus is called decrement operator. Okay, so I plus plus simply means I is equal to I plus one, and I minus minus simply means I is equal to I minus one. So these are but some syntax that actually we have been some provided in the C language. So you just want to, sometimes you'll just especially see that I is equal to I plus one in the program. Sometimes, especially in the pseudo code, like pseudo code actually don't follow any programming language, but it's particular to C. So pseudo code, sometimes if you are trying to run this program, it may happen that there instead of I minus one, it's written I minus minus, or sometimes I plus plus. So this thing you just understand whether simply I is equal to I minus one, and for this thing I is equal to I plus one. Just do the same thing. No any process. You don't just some other way we can write the same thing using the increment operator. So this thing is called increment operator, and this minus minus thing is called decrement operator. Okay, so same thing. There is no such fancy, some fancy way to write this thing, and especially when actually you go with the writing a lot of programs, so it's like writing same variable again and again. So this thing why people just write this way. Okay, so now we just some more variables, some more way you can do the same thing. So now the thing is, let's say we are writing num is equal to num plus one. Okay, so another way after before writing num plus plus, so another way can be or is to write num is equal to num plus equal to 1. So this thing actually translate to this way also, or it can be translated to this way also. Okay, the same thing is there, this particular thing is same. So whenever you want to do this particular kind of thing, you can do this by this way, and these are called compound assignment operator. So the name is not important. This thing is that you can also write this as this way. Other thing you can also do, you can also write, like if you want to decrement something, num is equal to num minus equal to 1. If you want to multiply something, you can also do num into equal to whatever the number is, let's say 5. Or maybe you can also do division thing, division equal to something, some number. Okay, so this particular thing is there. Yeah, yeah. So multiply means just let's go to this factorial thing. Where is the factorial thing? Okay, so like whatever you are doing, we are just multiplying the factorial by n. Okay, so this particular number fact is equal to fact into n actually can be written by using the compound assignment operator as fact into equal to n. It's the same thing. So I told you, if you're trying to multiply some number n by the same variable on which you are storing it, you can do this by this way also. And for similarly for the plus minus everything, like num plus one can be written as num uh, plus equal to one. Okay, if you are trying to do minus something like I is equal to I minus one, you can write same thing as I minus equal to one. And for the multiplication part, if fact is equal to fact into one, you can translate it into this way also. So you can instant means exclusively write this particular instruction at this way. This is particular means completely valid instruction. It will work. Okay, so these things are called like compound assignment operator, and there's other thing also. Like for plus, minus, division. There are other thing. In fact, for the modulo also. So sometimes like num is equal to like if you are trying to do something like this, maybe so these things is always valid. You can do this by this way also. Okay, and then there is the post increment and pre increment. So these are the no like same thing that I discussed. Key, if you are trying to use this plus plus thing inside the loop condition, so it has some different special meaning. So what's the meaning here? So just let's read this paragraph together. So firstly, the comparison of the value of I with 10 is performed, and then incrementation of I takes place. So here you can say that sorry, here you can say that the I plus plus less than equal to 10. So first of all means here the two-step procedure is there. So first what we'll do, it will compare compare with 10 in the when the plus plus is written after the variable name. comparison it made first, and second what happened in the second time, this particular thing, incrementation of I takes place. So just let's forget about everything and just focus on what this thing is happening here. So num is equal to 0. Okay, so first when this loop is run, what it will do, it will first do the comparison. Yes, 0 is less than equal to 10, it's true statement. And then what it will do, it will do the incrementation. Okay, it will do the incrementation part. When it will do the incrementation part, the number of the value of num will be changed from 0 to 1, because plus plus only increase value by 1. Okay, so plus plus only will increase value by 1. So number, the value of num is equal to 1 here, so 1 will be printed. Again it will go there and it will again compare. So 1 is compared with the 10, it's true statement. Then what it will do, it will increment this particular thing. So num is get increased by plus 1, then so it will become 2, and then it keep printing the same value same way by 10. So when 10 is there, it will compare 10 less than equal to 10, it's 2, and then it will what it will do, it will increment this particular thing. So num plus plus when written inside this particular thing is a two-step procedure. I told now, first comparison will be done, then incrementation will be done. Then it will increment that particular thing, and num value of num will become 11. Then again it will make comparison, 11 less than equal to 10, now it's false. That's why it will come out of this particular loop. So this is called post increment. And similarly, like plus plus num is there, so this is called pre increment. Pre increment means first increment is done, then comparison is done. So this particular thing is included in this slide. So you can say that this particular thing plus plus num is called pre increment. So what will happen when I is slide with 0? First it will its value will be incremented. So value will become 1, then it will compare, it's true, it will get printed, and similarly the thing, everything will be followed from here. Okay, so see that here 11 will not appear, because when 9 is printed, the value of this particular thing will become 10, and this particular thing prints the 10. And then again if value comes here, the plus plus means it will increment the 10 first. When the 10 will be incremented, it will go to 11, and 11 compared to this particular thing, it will not be true. That's why it will come out of this particular loop. So here, incrementation is done first and comparison is done after that. But in this particular case, first comparison is done, then incrementation is done. So first the value will be compared, then if it's true, then the incrementation part will be done. Okay. Okay, so this was the thing for the while loop. I know like there are some particular thing here. So let's say we when the 11 is there, like num plus plus. So when number is 10, and it's compared, then it will become what it will become, it will become 11, and it will be printed. So when again if num is equal to 11, it will again go to this place. Okay, again what comparison will be made? So comparison is not true. Okay, comparison not true, and then this particular line of code will not run. Okay, so this particular thing, post increment, pre increment, sometimes these are the way, something some conditions can be defined also. Okay, so this thing is there. And I actually told you while loop are of like three types: while loop, for loop. So while loop is there, but like a lot of applications questions can be made on the while loop, and same loop can be transformed into for loop. So whatever you can do with the for loop, you can also do with the while loop. And the thing is that there are a lot of questions now that can be made here. Okay, a lot of different types of questions that can be made. So one problem is to just let me discuss one coding questions if you can do by yourself. So like there's a number given. Okay, number is equal to 3, 4, 5, 6. Okay, there's a number given. What you need to do, you need to find the sum of each digit. So here it essentially means 3 plus 4 plus 5 plus 6. Okay, so this particular comes to 4, 3, 7, 5, 18. Okay, so this particular thing you need to done. So the user will give an input number of means a number as input, whatever the input may be, 3, 4, 5, 6, or 1, 2, 3, and you need to calculate the what you can say, multiplication, or maybe what you need to say, you need to calculate the addition of all the digit of this particular number. So this thing can be done using the especially loop thing. Okay, so can anyone just do anyone have idea like how to solve this type of questions? No, no, no. the user will be given, means the number will be given by the user, whatever it numbers can be different. Yeah. So yeah, separated means they user will just will say that user enter a number, he will enter some number 1561 as like this. Okay, so this is a integer value. Yeah. Okay, so yeah, please, yeah, that approach is also true. Yeah. Yeah. Okay. Yeah. Yeah. Yeah, yeah. You can do that same way. Okay. Oh, so it means you can access the digit one by one. So 1 2 3 divided by 10 will, like, give you the remainder, which is 3. And when it will so it's a modulo operator. And yeah, modulo operator. And when it will, again, it will divide 1 2 3 by 10, it will give you 12. We can repeat the same. Yeah, same. Yeah, yeah, definitely. So hmm. You can do that, and this way you can also calculate each number one by one, and just you can do the summation. Like the lot of problems are actually framed like this. So sometimes it may someone has asked that you are given a number. So let's say you are given number 1221, and there is a concept of palindrome of number. So like palindrome means anything that is same, whether you are taking it from the beginning, whether you're taking from the last. Okay, so this particular number, when it will start reading from the beginning, 1221, same thing will be there. But like some number like 132, it's not a palindrome, because 132 from the start, but if you end from the beginning, it will become 231. So this, both the number are not the same. Okay, both the number are not same. So a questions can be given a number, you need to find if it's a palindrome number or not. So palindrome number simply means that any number which, when translated from backward, actually give you the same number. Okay, so a similar idea is to, like, access the number this way, and try to construct the another number. So like, this particular thing is that if first time you got the 3, then what you need to do, just uh, what you can say that he just means just try to make a number by accessing the same number, each digit, and then make another number. So like it will become, initially become 3 to 1, and then compare whatever your original number is with the number that you have made, and just if both are equal, then that will be a palindrome number, and if it's not, it will not be a palindrome number. But like this program is something that you need to construct. But whenever you are given a, what you can say, some bunch of code, the thing is that it may happens that the particular line of code is doing something like this. So it may happen that sometime the particular line of code is for finding the palindrome, for finding the factorial, for finding the, like, ncr, whatever the thing is that. So like when a lot of application of this type of program, actually it becomes easy for you to simulate the output, so what the particular thing is doing. So let's say if you have not calculated factorial of any number any times, means just you will learn the syntax only, and if you sit for the exam and just see a lot of syntax there, just you don't know what the particular code is doing. So let's say you arrive at a conclusion that it find the factorial of a number. So you just see that, oh, means a factorial can be found at a program. That's why these things are important. If you know a lot of application of the code, it will become very easy and very fast. You will become to simulate what the program is doing, because you have seen this same type of thing a lot of times. Okay, so a lot of applications of for loop is sorry a loop is given in the book also. And I think if you have already know you already know the programming, you must have run a lot of code related to for loop or something some else. Okay, so like while loop we already discussed. So time now is almost we have crossed, but let me just discard one two slide, and then we will just end this particular thing. So like the while loop, for loop is always there, also there. And like in for loop, the simple this thing is a slightly
different than while loop. So there are three main things. Okay, three things that uh, we found that in while loop you also used to initialize the counter. So here you need to initialize the counter, you need to test the counter, and you need to increment the counter. Okay, so we there also we had a counter. Then inside the while loop we are testing that counter or testing some condition, and later in the loop we are incrementing that particular counter. Okay, so we had this particular kind of thing. So same thing is there in the for loop also, but the way for loop is written is different than the while loop. So everything is written inside the this parenthesis after the for word. Okay, so if you are a beginner, and especially you give a semicolon after each separating each particular entity. Okay, this particular separating each thing, and you give a semicolon, and out in the curly braces you can write particular line of code. Okay, so essentially same thing is there. Like we run the flow chart. We initialize something, then we test some condition. If it's true, then we again run the particular thing, and if it's false, we'll stop, and we'll keep running the loop until the particular condition is true. But like just let's see this particular thing with a example. Okay, so the idea is the same thing. Just we want to calculate the what you can say this simple interest kind of thing. Okay, so let's say the same while loop we had, like we want to calculate this particular thing three times. Okay, three times. So what we need to do first, we need to define a count. Count is the loop counter. Okay, loop counter it is. And what you need to see, you just see that we initialized count with one. So initialization takes place inside the for loop. It can also takes place outside the for loop. We will see some specific example, and we just check the condition. So you can see above that we had initialize counter, test counter, and increment counter. Okay, so we initialize the particular thing. We tested the loop whether it's less than equal to three or not, and if it's true, okay, if it's true, what it will do, it will just run this punch some line of code, and then it will come again to increment the particular thing. Okay, so it's not like everything done in the sequential way. First count is initially in the beginning of code. Count what is taken, then it's just run the condition, and again run the line of code if it's true, and then again it come back to do this incrementation. So you can understand the same thing with this flowchart. First count is equal to one is sliced, then is compared, then if it's true, then same line of code is run, and in the next way what it will do, it will just increase the value of count by one. Again same thing will be repeated. Okay, then again it will raise the value of count by one, and same thing is repeated until the condition become false, then we stop ultimately. Okay, so this particular thing is there. So it's the same thing, just initialize the counter, test the counter, and increment after this particular set of code is run each times. Okay, and this way the loop will keep running. It is also there, like for there the counter you can also increase by two if you want, you can also decrease by one you want. So the same thing that applies with the while condition, same thing apply here also. You can just manipulate it whatever you want, and you just do need to, but just practice. If you know this particular thing, that's okay, and if you don't know, just you can go and practice these type of things. So like same examples, what else I can say. So let's say you want to print so like I told ki this particular thing, initialization, test, increment, these things are there. Okay, so like there are some variation of for loop. Okay, so these things is there, just I wanted to show in a slide. So like whenever you are initializing int I is equal to something inside the for loop, that's particularly valid. But like if you don't want to initialize, you want just key whatever the initialization should come, it should come from the user. You can just do this thing also. So it simply means that when the code will run, it will ask the user a input. It will expect an input from the user. So let's say input user here given the 5. So what it will do, it will just initialize I with the 5, and I with the 5 it will initialize, and then run the code till the 10 come. So from I is equal to 5 to I is equal to 10. It will run the code, and it will keep printing 5, 6, 7, 8, 9, 10. So let's say user has given 4, or maybe user has given 3. So same way the thing actually runs. Okay. So it actually means that if you don't want to initialize, if you want to take input from user, you can just do the same thing. Just try this particular line of code inside this particular initialization part. Still there is semicolon, still there is a semicolon separated by this condition and increment part. And I told you increment you can do anyway. You can just do I is equal to I plus one, or I plus plus. So this thing actually I told you these things are there. Okay. Same thing if you just don't want to initialize anything here, just you want to initialize something before the loop. Okay, like this way. I is equal to 0 is initialized in the beginning of code. So just you can skip this part. Okay, just skip this part, but don't forget to put a semicolon, and just write a condition and the increment. So these are the some variation of for loop. Like this is in the part of C programming. And if you don't want to write the increment in this portion, also you want to write mention increment somewhere around in the code in the body of the for loop, you can also do that. Okay, you can also do that particular thing. So these things are just variation of for loop, but like a standard in the standard way, people generally use this way. Just initialize, just put the test counter, just the increment counter, because these things are there and these things are easy to understand. But obviously, the thing is that C programming allow you to just write this way. Okay, so these are the some different way that you can do that. Okay, and mm, so we how many slide we have now? Okay, it's just two slide. So just let me finish those two things also. So like the same thing we discussed the post incrementation and pre incrementation. This same thing is there. So like the way you don't want to mention any incrementation in this for loop. What you can do, you can mention the incrementation itself inside this comparison thing. Okay, and when you do this thing, we know that this is a post increment thing. Okay, so what is the thing is that the comparison as well as the incrementation is done through the statement. Okay, we know this particular thing. Since the plus plus is known as comes after I, first comparison is done. So we know that in the post incrementation, first comparison is done, and then incrementation is done. Post increment means it will be incremented after the comparison, and pre increment will increment before the comparison. So essentially, this particular line of code, what it will do, it will give you some output. What output it will give you? First comparison is done. So I is equal to zero, and I zero less than 10 is equal to true. But then increment will be done. So it will print number from 1 to dot 11. Okay, right? And what this will do, it will just make the incrementation first, then the comparison. So I is equal to 0 is first incremented, so it will become I is equal to 1. Then it will become compared, so it's true. So it will give number from 1 to till 10. Okay, so this particular thing is there. So like sometimes it happens that of some line of code is given and you are asked output, and it may written that key, like there are four options there, and it may written that key the four option is like key, it will give a number from 1 to 10, or it will give number from 1 to 11, or it will not give some output, or it will give something else. So we will just after few lectures we'll just start solving some CMI type of questions, CMI question itself. We'll see what the things are there and how these things are becoming important. But it's the same thing that we discussed in the while loop. But the way we write in the for loop is the different. And okay, so nesting of loop is something that we will focus also on the next class. But for now, just let me introduce the nesting of loop. So like the way we introduced if else and we nested if else actually can be done with the for loop also. So inside one for loop, actually we can also keep the other for loop also. Okay, so these things is called a nested for loop. Nested for loop means you are trying to make a nest, trying to write the for loop inside the another for loop. But the two thing that is most important here is just don't try to forget the curly braces, because if you just mismatch the curly braces, the output will be totally different from what you have expected. Okay, so the thing is that just let's say you want to print a table of number from I is equal to 1 to 5. What you want to do, you want to print a table of number for I is equal to 1, you want to print a table for I is equal to 2, you want to print a table like this way. So like this is the table of 1, this is the table of 2, and similarly there will be other table like for table of 3, 4, 5. So let's see how we can do it in the nesting of loop. So similarly you can do this thing with the while loop also, you can do this thing with the for loop also. So just for the sake of introduction, just let me just introduce this way. So like just for now, just let's focus on this particular part, this particular simple part. Okay, simple. How to calculate the table of 1. Okay, uh, so we can see that we just keep this particular thing constant and keep incrementing this particular thing by 1. Okay, so this is the observation, and when you multiply those two things, you will get the output. What will happen if you want to table of 2? Just same thing, keep this particular thing constant by 2 and keep incrementing this thing by 1. Okay, so same thing is done here. Okay, so for I is equal to 1, I less than 5, I is equal to I plus 1. So for I is equal to 1, what will happen? J is equal to 1 will follow inside this for loop. J is equal to 1 is follow, and it will just write percent d into percent d is equal to percent d. is this means I into j is equal to I into j. Okay, so that's a particular thing is there. So I here, j here, and whatever the result of I into j here is printed. So like we'll mainly discussing this thing tomorrow also. So for now, just try to run this code in your system, and just let's see what is the output of this code. Okay, you can just try to increase this particular 5 by different numbers and try to simulate output. But it will definitely discuss the thing tomorrow also. So if you have any questions till now, just let me know, or maybe we can close the class. Okay, this thing, uh, right? This thing, right? Yeah. Okay. Okay. So in the post increment, the word itself says that post incrementing first comparison will be done and increment will done after the comparison. Okay. Post means after something. So instantly first the comparison will be done. Okay. So sorry, so this will start from zero, I think. So what will happen? I is equal to zero. Okay. So first what will be done? Comparison will be done. So zero less than equal to 10. Is it true? Yeah, it's true. Okay. Then in same way, same thing, same place, at the same place, then the increment will be done. So increment done will keep the this particular thing as one. Okay. Obviously zero will increment it one and I one will be printed. Then what will happen? It will again come to this place. So I is equal to 1 now. And what the first thing is done? First is comparison is done. So 1 is less than 10. Yeah, it's true. Yeah, right. And then what it will done? It will then increment the value. So here two operations are simultaneously taking place. First comparison is happening. It's comparing with the 10. And then what is happening? It just increments this particular value. Okay, so now one is increased towards the 2. So this way the things follow. So when the I is equal to 10, I is equal to 10, 10 less than equal to 10 is true. Yeah, it's true. And then what it will do, it will increase the value of I by 1, which will be the 11. And when again the particular thing is come, 11 less than equal to 2, it is true. No, it's not true. Okay, so in comparison it false, and then the program will come out of the loop. Okay, so is it clear now? So like in the beginning itself, when the I is equal to zero, okay. So what is happening? This thing, this incrementation is increasing the value of I by one. So first comparison is doing means I means which is zero less than equal to 10 is true. Yeah, it's true, right? And then incrementation is happening at the same point of time. So this I is equal to becoming one. That's why this particular value is not coming. Okay, so here's a task for you. You just run this program and put here a printf statement after the while loop. Okay, after the while loop, and try to print what is the value of I after the loop has been run. So what do you think? Will it be 11 or 12? Because obviously, if it's a false, comparison is done. Incrementation must have been done, right? So just let me know what's the value of I is if it's a 11 or if it's 12. Because after 11 the loop will execute. Sorry, loop will end. But whether after the last comparison was made, were the value of I were increased or not? So just let me know that. Yeah. Okay. So just let me know because this is something that I also just this thing came in my mind and then I also look towards it. Okay. So guys, I just told ki till now we are having some focus on some more problems in the loop section because those things are important. And there is something called do while loop, break, continue. So these things are there. This thing will not take much time. Then there is a function. Then there is array. Then there is some portion of this data structure, and there's some problem solving class. So this thing will take one class plus one class, one more examples of for loop. This function introducing function will take I think one class. Array will take one class, and binary tree and binary search tree will take one class. And for problem solving, we'll keep doing a lot of classes after the this thing end also. And meanwhile, we will also do one class at least. So these six classes, six plus one, maybe seven classes, we need to do programming. So I was really thinking to start a probability part, but today is Wednesday, so just let me introduce this complete this at least this part also, because if we leave this thing in the middle, we have so. Uh, I think towards the end of this week, maybe on Friday or Saturday, we just keep a probability class. Or if it's not happening, then we'll just see if on Monday we can do that. So it's not like important to complete the thing that we have started. And these things are not going to take a lot of time, because after completing this part, you'll be also able to solve a lot of questions and keep practicing the things. So we will see how we can do that. Okay.